Alright, so we're looking at another type of pictorial drawing, and this time we're looking at orthographic projection, right? So the last time we looked at oblique projection, and we already looked at isometric projection. So what is orthographic projection? We know that orthographic projection is a method of representing a 3D object in 2D. So it's just like the previous types of pictorial drawing, right? The only difference is you use multiple views or you use multiple drawings to represent these objects, right? So the purpose is to give someone a more clear and detailed representation of the object from different views, and each view would be a two-dimensional view. And in technical drawing, we also call them elevations, right? Now, the three views or the three elevations that you would use would be the front view, the end view, and the plan view, right? Another word that would be used to refer to the end view would be side, and another word to refer to the plan view would be the top view. So you need to know the planes of orthographic projection. We have three primary planes, right? You have the frontal plane, which is more commonly known as the vertical plane, and this would represent the front view of the object. So if you look at the two images here, you can see the abbreviation VP, which is the vertical plane, is showing the front view here for this rectangular block, right? Or you might know it as a cuboid. So we have the horizontal plane here, which would represent the top or the plan view, and this is for the abbreviation HP, and you can see that it's represented here on the other drawing as well. And then you have the profile plane, or it's also known as the side plane, which is this last one here, and it shows you the end view, right? Or some persons might say the side view, but more commonly CXC uses the end view, right? So we have two types of orthographic projection. We have first angle and we have third angle, and the difference between the two is basically the view arrangement here, which I'm going to show you just now. Alright, so for the first angle, the views are arranged in a clockwise sequence, where at the top left you would have the front view, towards the right you would have the end view, and right below the front view you would have the plan. Alright, and for third angle, it's basically flipped, or it's basically switched, right? Where the top view is above the front view, and the right view or the end view is placed to the right of the front view, right? Now, you're going to see here that the presentation also speaks about object placement, and it says that for first angle, the object is placed in the first quadrant, and for third angle, the object is placed in the third quadrant, right? So if you look at these two images here, you can see in the first image, for the first quadrant, this is where they're talking about the first angle, right? And you can see that each plane here, the vertical plane, the profile plane, and the horizontal plane, represents each view for this L-shaped block here, right? So for the vertical plane, you have the front view. For the profile plane, you have the side view or the end view, and for the horizontal plane, you have the plan view or the top view, right? And then for the third quadrant, you can see that they're showing you the horizontal plane and the vertical plane, right? Which would be the plan view and the end view. Now, I wouldn't recommend you going into much detail for these quadrants. The most important thing that you gotta remember is the positioning of the views, right? So you can see that this is force angle projection, where at the top right of the page you have the front view. Towards the right here you have the side view or the end view, and right below the front view you have the plan view here. And then for third angle, you can see that it's basically switched. The only difference is that on the bottom right you have the front view, above the front view you have the plan view, and towards the left here you can see that you have the end view, right? So the difference between them is basically just the positioning of the views, right? Front view, end view, plan view. So I would recommend that you actually memorize the positioning of the views, right? And most likely we're going to be using this one, which is the force angle projection, right? Um, for CXC in the paper 2 as well, they mostly use the force angle projection. But to be on the safe side, you should also know the third angle projection. So just for today, what you're going to do, you're going to make notes on what we went through here basically, and we're also going to construct the projection symbol that's shown here, right? But before we construct the projection symbol, let me tell you a little about it, right? So in technical drawing, we use these symbols to tell you if a drawing is either in first angle or if it's in third angle, right? And this is what you call a frustum, right? So all of you should know what a cone is. Basically, if you take a cone and you cut the part at the top, the pointy part, parallel to the base of the cone, you're going to have an object that looks like this, right? And this is what you call a frustum. So for first angle projection, you would have um, this part of the frustum being drawn first, and then the part with the circles here. And for third angle, it's basically switched around, right? So it's pretty easy to remember. It's not very difficult, and there is um, there's a calculation here basically that shows you how to draw the frustum. So we're going to go through that. It's not difficult.